Hi folks, thanks for stopping by. I'd like to talk today a little bit about mapping the flat Earth, which I started in part 1. I showed that the distances between cities were not consistent with the flat Earth model, but I didn't do any actual mapping. I'll try that today. In my preparation, I did a little research to find out what map making is all about, and I found that there are 4 main issues, shown here on this screen from a video called Introduction to Cartography. There's equivalence, which is proportions of areas to scale. There's conformality, which is the directions from any point to all others be correct. There's equidistance, which is linear distance being to scale. And then azimuthality, which is the directions from any single point to all others be correct. The Mercator projection map is created by projecting points outward from a sphere onto a cylinder, which is then unrolled. It scores low on equivalence. Note the proportions of Greenland are massively exaggerated, but it scores highest on conformality, showing accurate directions between any 2 points. It's excellent for navigation. No other flat map can compare. For example, from New York City to Cape Town, you'd set a course for 131 degrees from due north and then just head southeast. Now the well-known AE map also scores low on equivalence. For example, the equator is 57% oversize. Note the proportions of Australia, which are just stretched and distorted. But it's good on the last 2, but only with respect to the North Pole. If you live at the North Pole, this map is perfect, but it's hopeless for navigation. For example, if you're traveling from New York to Cape Town, this map says set a course to 71 degrees from due north and head northeast, and that's like 60 degrees off course. The map points to Morocco, but a check of the Mercator map shows that you're actually headed towards Ireland. No flat map of the globe Earth gets all 4 things correct, although there's no reason why a flat map of the flat Earth would have any problems whatsoever. If the Earth was flat, like a pool table, none of these would be any concern. A map of the Earth would easily show accurate scale proportions, azimuth angles from any points to all others could be easily found. Everything would be fine. The U.S. Army made a map-making movie, and I'm showing some frames of that here. They start with a baseline of 2 known points, and then triangulate a third. With a new point in one of the first 2, they triangulate a 4th point, and then just build outward from there. I'm going to use the same method. After choosing cities, the next step is collecting data, shown on this table. I used timeanddate.com and I cross-checked it with Google Maps and a German site called infernungsrechter.net, and they're all within 0.1%. So that's pretty darn good. For the drawings, I used a 2D CAD program called QCAD. If you're working with geometry, CAD is the way to go. I started with a baseline of 7,867 miles long. That's from Santiago to Anchorage, Alaska. Now Reykjavik is the first city that I'm going to add. It's 3,381 miles from Anchorage, so I drew a circle there with that radius. And it's 7,225 miles from Santiago, so I drew a circle there with that radius. Where the circles intersect, that's Reykjavik. Drawing lines from there back to Anchorage and Santiago, I deleted the circles and the first triangle is done. Now I'll use that same method for the triangles to follow, and there's no need to spell out every step. Using the data from the table that I showed earlier, I plotted East London from Reykjavik and Santiago, Nizhny Vartovsk from East London and Reykjavik, Sydney from Nizhny Vartovsk and East London, Anchorage from Sydney and Nizhny Santiago from Anchorage and Sydney, and Reykjavik from Santiago and Anchorage. Now this is my flat earth map of some cities around the world, and with correct to-scale distances. It has good equidistance. By that I mean the legs of the triangles are accurate, but if you didn't notice, the last triangle on the right is the same as the first one we started with. For map makers working from a globe, this isn't a problem, because it's understood that a globe is round and it just continues in all directions. So if you make your map and you find from cities on the left and their same cities on the right, well, it just means that you plotted more data than you needed. But for the flat earth map maker, this is poison. The earth is supposed to be flat like a pool table, and each ball on the table or each city on the flat earth can't be in more than one place at the same time. And the AE map, for all its faults, at least it shows each city only once. Now this problem of the cities repeating, this could be fixed by folding along the lines and overlapping the end triangles, or by rolling it up into a cone. But this defeats the whole purpose of having a flat earth map. A flat map of the flat earth should be flat. Now it has other problems too. The distance between Nizhny to Santiago is 10,035 miles. Now plotting that as a radius on the map, it overshoots it on one side and undershoots it on the other. So the map isn't even consistent with itself. And this points to a problem with maybe the data being possibly wrong. But I cross-checked the data with 3 well-established websites. They all agree within 0.1%. So that's not the problem. Now this next sketch, it kind of looks like a covered wagon or something. What I wanted to measure here was distances to the equator. So I drew circles with the radius of the right distance at Santiago and Sydney, and then I drew a line tangent to the circles, and then rotated the map until the line was level, and drew lines vertically through the cities, perpendicular to the equator, and then I had something to measure, which I did, and I'm showing the results in this table. The data for 2 cities are over, 2 are under, and the 2 that are correct, they're right because I set them that way. So this is a very serious indication that something's wrong with this map. So I decided to add another city to the map and see how that looked. I tried adding the city of Riyadh, Saudi Arabia to the center of the map, and I made this table of the data. Adding Riyadh like I did with the other cities, it winds up pointing in 4 different directions. And that's something that could never happen if the Earth was flat. Really, I mean, a flat map of the flat Earth should show each city in only one place. So the data is good, the method is good, so what's left to explain this? Could the established cartography technique of triangulation, in use since the 1500s, be flawed? Well, there is a flaw, but it's not with the method. Triangulation is used for mapping areas that are in a line of sight. It's not intended for mapping vast distances on a globe with points that are over the horizon. The flaw is applying a method for measuring small flat planes to a gigantic sphere. It's so huge that you can't even see 1/1,000,000th of it at one time. Still, it would have worked anyway if the Earth was flat. So I got a closing thought here on the Mercator map. His idea of projecting sphere coordinates onto a cylinder for purposes of navigation, that's just brilliant. And the success of this map is not proof, but it's evidence in favor of the idea that the Earth is round. The failure of triangulation to produce a flat Earth map in this video is similarly evidence that it's not flat. Now, I don't know how it can be argued that it is, but The theory just doesn't fit the facts. Well, that's all I got to say about this right now, but thanks for watching. It was kind of fun to make, and please check out my other Flat Earth videos. They're kind of cool, and I'll see you next time.